All right, section 7.3. Yesterday, so a recap, we did our triangle lab. We cut out triangles of all different shapes and sizes. We tore off 2 of the angles. We placed the angles next to each other, all 3 of them, and decided that they actually formed a straight line. What's a straight angle measure? 180. So if all 3 angles of a triangle form a straight angle, then that means every triangle in existence, all 3 angles add up to 180 degrees. That was really important. That's called the triangle sum theorem. Remember, a theorem is something that's been proven over and over again to be true. The second theorem we did was the triangle inequality theorem, which said that if you added the 2 shorter sides of a triangle together, they had to be larger than the longest side. How many of you were in a no triangle group yesterday? Was a little frustrating knowing that everybody around you was finished after like 10 seconds and you're wondering what you're doing wrong?
Yes.
I almost made someone cry in my last period. I was like a drill sergeant. I came around, I was like, we don't have time for this. Make the triangle. And they're like, I don't know how. And I finally was like, all right, everybody else that made a triangle, could you please go show them how to make their, and they walked over with so much swagger. They're like, all right, I'm gonna show you how it's done. And then they couldn't do it. So we learned something important that you probably didn't know about triangles, which is you can't just make a triangle with 3 random line segments. In order for the triangle to work, Lucas, in order for the triangle to work, the 2 short sides have to add up to be longer than the longest side. Otherwise, if your longest side's too long and the 2 short sides are too short, they're never going to connect. And you end up with this, which is what happened with our other groups, right? So let's review that because that's going to be on your quiz Friday. I'm going to give you 3 line segments, just like I did on the worksheet you guys got yesterday, which we'll get to. I'm going to give you 3 line segments and ask you if they make a triangle or not. So how about these 3? Red, blue, and green. If I gave you 4 pieces of yarn and said, all right, grab the red, blue, and green ones and make a triangle, would you be able to?
No.
Why not? You're right. The red's 2, the blue's 4, the green is 6. The 2 short sides have to add up to be larger or bigger, greater than. That's why they call it the triangle inequality theorem, because the greater than symbol is an inequality symbol. Since 6 is not greater than 6, the answer to that is no, you can't make a triangle. Okay? You can't make a triangle with those 3 sides. What would end up happening actually is the only time you'd be able to get the red and blue triangle to connect to the green one and then touch is when you're laying them on top of the green one. Because it's 6, just like the green. And so that doesn't make a triangle, just makes a really thick piece of yarn. The blue, the green, and the purple. So the next example is blue, which is 4, green, which is 6, and purple, which is 7. If you add the 2 shorter sides together, what will you get? 10. Is 10 greater than 7? Yes. Then you can form a triangle with those line segments. What about red, blue, and purple? If I said grab the red, the blue, and the purple, make a triangle. What's the red and the blue add up to? Is 6 greater than 7? No. You can't make a triangle. What if I said grab the red, the green, and the purple? What's the 2 shorter sides add up to? 8. Is 8 greater than 7? Yes. So you can't make a triangle.
Oh,
Yes.
it's like our isosceles.
Yeah. When you did an extension. Yeah. All right. Moving into today's lesson then. Does this make sense for everybody? The 2 smaller sides have to add up to be bigger than the longest side. Not equal, bigger, not greater than or equal to, just greater than. Yes, Lainey. Gotcha. So if you're actually asking me, like, how do I show work for this? This is how I show my work. Show me what they add up to. Like, for example, B, we said this makes a triangle. Don't just put yes, it makes a triangle. Show me that you're going to get 10 is greater than 7. Show me that the 2 long sides add up. Show me what they add up to. And that way you can prove that they do add up to be longer than 7. All right. This is today's lesson. And you probably already know a lot of this stuff in today's lesson. Today, we're going to be classifying triangles by their angles and by their sides. So here are the 4 ways you can classify triangles by their angles. You can have acute triangles that have 3 acute angles. You can have an obtuse triangle that has one obtuse angle. You can have a right triangle that has one right angle. And if you have a really special triangle and all three angles are equal, you can say it's equiangular, equiangular. All right. We'll talk more about that in a second. Why is it that to be an acute triangle, you have to have all acute angles? Why is just having one not good enough? Maddie? Yeah, you're right. The obtuse triangle also has acute angles. In fact, so does the right triangle. Every triangle in existence has to have at least two acute angles. Because if one's obtuse, obtuse angles are more than 90. Since we learned yesterday there's 180 degrees in every triangle, if you've already got one angle that's bigger than 90, there's less than 90 degrees left to split among the other two. So they have to be acute. So every triangle has to have two acute angles. So just looking at a triangle and say, oh, there's an acute angle. This is an acute triangle. No, it has to have all three acute angles. And some of them do. Okay. Now, would you say the equiangular triangle is an acute triangle? Yeah, they're all three acute angles. In fact, the equiangular triangle is special because without me giving you any other information, you can tell me how big each of those angles are. They're all three the same. You know they add up to 180. How big is each of those angles? Jude?
45, 45, and 90.
Nope, they're all three the same, Jude. Lucas? You're right, it's 60. Take 180 degrees, split it three ways. Each angle is going to be 60 degrees. So in an equiangular triangle, all three angles will be 60 degrees. So you could say every equiangular triangle is also an acute triangle. Does that make sense? Now, if in a right triangle, you could tell me one of them is 90 degrees, but you wouldn't be able to tell me what the other two are unless I told you at least one of the other ones. Then you could tell me what the third one is. All right, so you can classify triangles by their angles. You can classify triangles by their sides. You can see period one didn't get very far because I spent so much time on the worksheet, which I'll get to later. There are three ways to classify triangles by their sides. You can say a scalene triangle. A scalene triangle has 0 congruent sides, meaning all three are different. All three sides are different. An isosceles triangle has 2 sides that are the same. Could be the top two, bottom, it doesn't really matter. It's just 2 sides. And then an equilateral triangle has all 3 sides being the same. So you got equiangular means 3 equal angles. Equilateral means 3 equal sides. Remember we said lateral means side. We found the surface area of our prisms. We said the lateral sides were the ones, right? So you see in these triangles, you've seen these red arcs. Okay, and you see these red tick marks. And those tick marks, those red arcs and tick marks indicate congruent sides and angles. So for example, the 3 tick marks that you see on that last one show you all 3 of those sides are the same. The 2 that you see on the one in the middle, the isosceles triangle, shows you that 2 of the sides are the same. So if you see those tick marks, you know what they mean now. Why is there no tick marks on the scalene triangle? Yeah, no sides are the same. In fact, if they were going to put tick marks, they'd have to do this. None of them have the same amount of tick marks, so none of the sides are the same. So why put them at all, right? That's why they didn't put them. Okay, so yeah, if you see the same number of tick marks, indicate congruent sides. Just so you know. All right, so we're going to classify each triangle by its angles and by its sides, starting with this red one, example A. In example A, let's start by classifying it by its angles. Thomas, is this an acute, right, or obtuse triangle? It is obtuse, you're correct. Yeah. To be an obtuse triangle, all it takes is one obtuse angle, one angle that's over 90 degrees. The other 2 angles are always going to be acute. You're always going to have 2 acute angles. So don't look at the acute angles. Instead, look to see if you can see a right angle or an obtuse angle. You don't see a right angle or an obtuse angle, that means all 3 of them are acute, then you know it's an acute triangle then. Jude.
I was always trying to figure out obtuse angle because obtuse angle is fat.
Awesome.
Like has a big number.
Like obtuse, obese kind of thing.
Obtuse.
Interesting. How many tick marks do you see? Any sides that are the same on this one? No. So what do we call a triangle that doesn't have any equal sides? Scalene. Scalene. S-C-A-L-E-N-E. Scalene. Fortunately, spelling's not going to count on your quiz Friday. I just need to know what word you're trying to spell. So it has to be close, but like if you know, if you put like I don't know, scholarship, I'm not going to count it right. But if you get the C and you put saline or something like that, I would understand. Example B. Example B has 2 equal angles and 2 equal sides. And are any of the angles right or obtuse? No? Okay, so all 3 angles are acute. So this is an acute triangle. And what do we call a triangle that has 2 congruent sides? Isosceles. I-S-O. Sorry. Yeah, it is ISO. ISO. S-C-E-L-E-S. Isosceles. It's a silent C. This is the one that everyone has the hardest time spelling. Isosceles. Isosceles. All right, moving on to C. We're going to classify it by its angles first. Do you see a right angle or an obtuse angle? Maddox, you see a right angle? So this is a right triangle. Are any of the sides congruent? Yes, how many? 2. So this one's also isosceles. The next one, do you see any angles that are right or obtuse? No, so it's an acute. Okay, if they're all 3 acute, then you can say it's an acute triangle. How many sides are the same? All of them. So what do we call a triangle with 3 congruent sides? Equilateral. Equilateral. Now, I would also accept a different answer for this triangle. Instead of saying it's acute equilateral, you could also say it's an equiangular equilateral. I don't know if I'm going to be able to fit that on the screen. Let's see if I can move this over. All right. Because did you notice not only does it have 3 tick marks indicating all 3 sides are equal, but also 3 arc marks, arcs, 3 of those red arcs showing you that all 3 of the angles are equal. So it's equiangular equilateral, or I would accept acute equilateral. Okay, so you have to give me 1 angle classification, either acute or equiangular, and then 1 side classification, which is just equilateral. In fact, I've been noticing a trend here. Have you noticed that every time we've had an isosceles triangle with 2 equal sides, there's been 2 equal angles? That happened again here. We had 2 equal sides for this isosceles triangle, and we had 2 equal angles, right? Here we have 3 equal sides, 3 equal angles. How many equal sides do we have here? None. How many equal angles? Now, if all 3 sides are different, all 3 angles are also different. Now, for the angle classification, do you see a right or an obtuse angle here? You see a right angle, so this is a right triangle. If you don't see a right or obtuse angle and they're all 3 acute, then that's when you know it's acute. But you can't look at one angle and say, oh, it has an acute angle, this must be acute, because every triangle is going to have 2 acute angles. So this is a right triangle. And since you already told me that none of the sides are the same, this must be scalene. Right, scalene. And then example F, your last one here. Do you see a right or obtuse angle, Jude?
It's obtuse and it is, it's isosceles.
Nice job. Yeah, we see that obtuse angle up here, the 100-degree angle, that's bigger than 90. And then because 2 sides are the same, this makes this isosceles. And again, you notice the pattern. 2 equal sides, and they're also showing 2 equal angles. 2 equal sides, 2 equal angles. So that's the next part of our notes. That's not just a pattern. That's always true. In a triangle, angles and sides relate to each other. If you have 3 congruent angles, you'll have 3 congruent sides. That's why we said that every equal angular triangle is also going to be equilateral, every one of them. Lucas, how big were the angles on an equal angular triangle? Don't remember? You weren't paying attention to what came out of your mouth 5 minutes ago? 60, there you go. Yeah, every equal angular triangle has 60-degree angles. So if I just told you that every equilateral triangle is equal angular, I guess we could say every equilateral triangle is going to have 3 60-degree angles then. Okay. If you have 2 congruent angles, you're going to have 2 congruent sides. And if you have no congruent angles, you're going to have no congruent sides. You'll notice I skipped one there. Well, you can't have one congruent side. Like, what's it congruent to? Nothing. So we just skip. If it has, yeah, if no sides are congruent, if one congruent side, there's nothing it's congruent to, then we're just going to say it doesn't have any congruent sides. Okay. Let's continue classifying our triangles. Is it acute, right, or obtuse? It is acute. That is correct. Is it scalene, isosceles, or equilateral? It is isosceles. Nice job. Now, they didn't put the tick marks on here, but they don't need to. If they're going to tell you that 2 angles are the same, these 70-degree angles, then that means that 2 of the sides are going to be the same. So you can just look at the angles of a triangle and know how to classify it by its side lengths as well. What about B? Is it acute, right, or obtuse? It's right. It's got a right angle here, right? So it's a right triangle. And they didn't give me the angle measures. So I'm going to have to refer to the tick marks, and they didn't put any. So is it scalene, isosceles, or equilateral, Maddox? Scalene. You know how I said chapter 7 was very vocab rich? This particular section in general is just all vocab. In fact, you don't even need your calculator to do this homework tonight. It's just going to be you writing down the triangles. Example C. I see 3 equal angles. What can I call this? I could say it's, you're right. I could say it's equilateral. It is equilateral because 3 equal angles means 3 equal sides. So that's how I classify it by its sides. How do I classify it by its angles then? I could say acute equilateral or equal angular. Is that how you spell equal angular? I'm going to go back up and look. That's why I don't count off for spelling, because I can barely spell stuff myself. E-Q-U-I-A. Okay, so there is 3 vowels in a row. It just looked weird, but that's how it's supposed to be spelled. All right. Example D. Look at the angle measurements. Are any of them 90 or above? Yes. So is this a right or an obtuse triangle? Do you have an answer? Hang on, we're going to finish this in just a second. Yes, Lucas? It is obtuse. Okay, it is obtuse. Are any of the angle measurements the same? No. So none of the sides are going to be the same. So obtuse, scalene. In example E, are any of the angles 90 or above? No, not here. 85 is as big as it gets. Is 85 a right or an obtuse angle? No, less than 90. So they're all 3 acute. This is an acute triangle. Obviously not equal angular though, just acute. Are any of the sides the same? No, because none of the angles are the same. So this is acute, scalene. All right. And then something that you might see on the iLearn test, they're going to ask you about a unique triangle. I'm going to talk about what that is for just a second because we're almost done. I'm going to ask you some questions about some unique triangles. So it says a unique triangle has no equivalent, which means there's no other triangle with the same dimensions and shape. It is one of a kind. So if I told you I need you to draw a triangle and then I gave you these descriptions, draw a triangle that has this, this, and this. If I give you enough of those descriptions, then regardless of how I tell you to draw it, it's all going to look the same. Hello? That was pointless. So for example, if I said, draw a triangle, and I had, you had rulers and protractors to measure your angles. If I said, draw a triangle that has a 4-inch side, a 5-inch side, and a 6-inch side, I just gave you 3 sides. Well, according to this, if I give you 3 sides of a triangle, every one of your triangles is going to look exactly the same because that triangle is unique. There's only one like it. So all the triangles you guys draw, although someone might have drawn a triangle like this and someone may have rotated it, they're all going to be the same exact triangle. Because if I give you 3 sides of a triangle, that triangle is going to be unique. Okay. If I give you, if I say I need you to draw a triangle that has a 4-inch side and a 7-inch side, and they're going to meet at a 110-degree angle. So if I gave you 2 sides and I told you the angle between them, the SAS triangle, sassy, then that would be unique. There's only one triangle like that one. So all your triangles would look exactly the same. If I told you 2 angles, and I told you, so I said, I need you to draw me a triangle that has a 45-degree angle, a 50-degree angle, and a 2-inch side. Well, that doesn't really matter if I give you the side that's between the 2 angles, or if I give you the side that's outside of those 2 angles, those are also unique triangles. So these are the 4 ways, the 4 conditions. Oh, sorry. Yeah, these are the 4. This one's right here saying not unique. Okay, so these are the 4 conditions for a unique triangle. This one here is not unique. So if I told you, I need you to draw me a triangle that has a 6-inch side and an 11-inch side, and somewhere on that triangle, there's a 30-degree angle, you could see that everyone's triangle could look a little bit different because you don't know how long this side is. And that side is going to be determined by the angle. So if I say 30-degree angle there, or maybe you put your 30-degree angle there, that could be a little bit different triangle. So sometimes I could give you descriptions that aren't enough. And if I give you descriptions that aren't enough, like they're not all going to force you to make the same triangle, then you would say there's many triangles. There's also a possibility that results in no possible triangle. Can you think of an instance where I could give you 3 side lengths and there wouldn't be a triangle? That happened yesterday, right? So if I give you 3 side lengths, the 3 side lengths, the 2 shorter ones, have to add up to be what? Bigger than the long side, right? Otherwise, you won't have a triangle at all. So keep that in mind. So even though we have a theorem that says if I give you 3 sides, it makes a triangle, we have to assume those 3 sides work, right? Also, what do all triangles, when I add their angles together, add up to? 180. So if I give you 3 angle measurements and you added them up and you got 190, does that make a triangle? Yeah. Okay. All right. So let's finish out our notes then. Determine whether you can construct many, 1 unique, or no triangles with the given descriptions. A triangle with 12, 15, and 16 centimeter sides. First of all, does that triangle exist? What do the 2 shorter sides add up to? 27. Is 27 bigger than 16? Okay, 27. Okay, so we could make a triangle. The question is, now that we know that we could make a triangle, is each of your triangles going to be different? And there'd be many different ones? Or are they all unique and it's the same exact one? Well, according to our theorem up here, if I give you 3 side lengths, that's going to make a unique triangle. So then if I said, everybody get your rulers out and draw a 12, 15, and 16 centimeter side, and then connect them together, everyone's triangle is going to look the same. The answer here is 1 or 1 unique triangle. Remember, unique means 1 of a kind. So if I gave you the descriptions and that was a 1 of a kind triangle, then everybody's going to have that same triangle. What if I gave you a triangle and I said the angle measurements have to be 45, 36, and 99? Can someone tell me what 45 plus 36 plus 99 is? Does it add up to 180? You sure? I need more than one person checking the math on this. It adds up to 180. Okay. How many triangles add up to 180? All of them. So if I told you the 3 angle measurements of a triangle, I didn't tell you how big the sides were. Is there a theorem up here? So you actually probably want to refer to your notes. Is there a theorem up here that says AAA? So if I give you the 3 angles of a triangle and that's it, and I don't give you any sides, then all your triangles are going to look different. They're all going to look different. Yeah, they'll have these angles, but I never told you how big the sides were. So you can make the sides long or short or whatever you wanted to do. So the answer to B would be there's many different triangles you could draw. But at least it exists, right? We know that if you have these 3 angles, they're going to add to 180. So triangles exist, but they're all going to be different. What about a triangle with 50, 70, and 100-degree angles? What's that add up to, Natalie? Does a triangle with 220 degrees exist, Natalie? No. So you couldn't make a triangle with those angle measurements. Yeah, they do have to add up to 180. If they don't add up to 180, you don't have a triangle at all. What if I said you have one angle measurement of 60 and 1 4-centimeter side? That's one angle, that's one side. Are there anything up here that says AS, just angle side? No, that's not enough. So everyone's triangle is going to look different. So this would be an example of when I would write the word many. Here's my 60-degree angle. Whoa, that just curved. I don't want to do that. There's my 60-degree angle. That's 60 degrees right there. I know that one side is going to be 4 centimeters, or 4 centimeters, but I never told you how long the other side had to be. So you could make it as long as you wanted to. You can make it like that. You could extend it, make it like that. You could extend it. So everyone's triangle is going to look different for this one. Okay. Example E, a scalene triangle with a 3-centimeter side and a 7-centimeter side. Is there a theorem up here that says side, side? Nope. So it's going to be many. I can make many triangles because no one told me what the other side had to be. If that side longer, it's going to have a bigger angle. If that side short, it's going to have a smaller angle. All of our triangles could look different. What if I told you that I needed an isosceles triangle with 2 4-inch sides that meet at an 80-degree angle? Side, side, and then they meet at an 80-degree angle. Do I have a side angle side theorem? Ah, the sassy one. I do. I do have a sassy triangle. That's a sassy triangle right there. And that means that sassy triangle is going to be unique. Or you could put 1. Means it's the only one in existence, right? If I said draw that triangle, you're all going to draw me the same triangle because it's the only one like it. An isosceles triangle with 2 2-inch sides and a 5-inch side. Do I have a theorem that says side, side, side? I do. So this would be one unique triangle, except it's not. If I put one unique triangle, this would be wrong. It's not what? Why isn't it a triangle? Because the 2 shorter sides don't add up to be bigger than the long side. I have to pay attention to that. You're right. So if I add the 2 shorter sides together, they have to be bigger than 5. And guess what? They're not. 4 is not bigger than 5. So my answer here is no triangle. So make sure when I give you the 3 sides, you don't just automatically put, yeah, that's one triangle. That's unique. Make sure they actually make a triangle first. Then it would be unique. A right triangle with 3 congruent sides. Can you have a triangle with 3 congruent sides? Sure you could, an equilateral triangle. And Lucas, what does every angle on an equilateral triangle have to add up or have to be? 60. Can I have a right triangle that's equilateral? Didn't we say if it has 3 equal sides, it has to have 3 equal angles? You can't have a triangle with 3 90-degree angles. It has to be 3 60-degree angles, right? This doesn't work. So this would be no triangle. All right, there you go. Lane, if you want to use the restroom, go ahead. Okay, I'll make sure we got through that part because that's the new part. That's the new part of the lesson. You guys already know how to classify triangles and isosceles. You've already talked about isosceles triangles and stuff like that before. Although it's good to review that.